Okay, for people joining this meeting, this is a continuation of a design discussion about chemistry functionality for Wolfram language version 12.3. Okay, so I'm seeing here improvements to molecule draw and new plot themes for MoleculePlot 3D after 12.3. Okay, so what we looked at here last time was, I thought this had been renamed already.
Yes, it's now a molecule identifier lookup. So I just grayed out the bullet points that we touched on rather than fully updating them.
Okay, all right. So, okay, so the first thing here is molecule substructure count. Is that the first thing I should look at here?
Yes, it should be relatively easy to say yes or no to. Not terribly exciting, but useful when next to find molecule substructure or molecule contains Q.
Okay, I'm not buying. I mean, if it's find molecule substructure, why isn't molecule substructure cases? Do you understand what I'm saying? Why isn't find molecule substructure otherwise known? If this is molecule, if this is counting what find molecule substructure finds, right? Then this shouldn't be a find. You understand what I'm saying?
I do. Yeah, I hadn't thought of that when so I just based it off of find graph isomorphism when we were designing that.
I think the reason it's called find graph isomorphism is because it may fail. Can your find molecule substructure fail?
Yes, if it's not there.
No.
So it returns an empty list.
That's not what I mean. Find graph isomorphism. I believe there are isomorphic graphs that it will not determine isomorphism for. Do you understand what I'm saying? I think we changed this. I think there's an isomorphic graph queue, right? Oh God, we've still got this stupid thing going here. Okay, so I can't really trust anybody else to send this message correctly. I have to do it myself. Okay, why is this called find graph? Okay, finds an isomorphism that maps the graph by renaming vertices. So can this fail or not? Apparently not.
Maybe find cycle is a better equivalent because that's more obvious what the parallel to a molecule is.
Okay, but find molecule substructure, you believe if there is substructure, it will find it, correct?
Yes.
It's not heuristic, it's not anything else. It will find it.
So I didn't write the algorithm myself, so I can't guarantee that.
I understand that, but in principle, it will find it.
Yes.
Okay. And it will find it in the form that find graph isomorphism does, where it's telling you the mapping from one molecule to the other. Is that correct?
Yes.
So, and then molecule contains Q. I see.
It essentially returns whether or not that would return an empty list without populating that return.
Yeah. Seems okay to me. This seems okay to me. No, is an operator form that represents is how you have to write that, right? You know, just go look at someplace else how to do it, right? That's not correct. I don't know why you pick such an incredibly, you know, look, I got to comment on this, okay? This isn't the way these examples should work. There should not be two steps. It's got to be one step. Okay? Am I making sense?
Right. So
Do you understand this? Don't ever do it this way. We tried to, okay, this is broken for many different reasons, right? We don't want to have to show, you know, it doesn't copy properly if you have two steps like this. And it also is more difficult to understand. So just pick a molecule that's short enough, stick it in there again. Am I making sense?
yes.
Okay, fine. And please make sure you don't do this thing of defining something. You know, that's a very expensive operation in examples, to define something and then use it later. So, if, you know, you only do that if you really, really, really have to. Does that make sense?
Yes.
Okay. Okay. Molecule value plot.
Right. So I rather like these functions that were put in the function repository, but they could very easily, I think, be system functions.
I think
So,
they're a good idea. Yes, they seem like a good idea to me. I mean, they seem like, except we don't really have graph value plot. I mean, we have that, I think, as in the function repository, but I don't think we've ever put that. And that would be something that would be worth thinking through how that works. Do you see what I'm saying?
Right. I mean, it could use any type of vertex or edge annotation in the same way.
Well, can you do edge annotations here?
No. So I think of bond type, and I think of atomic number as being edge and vertex annotations in the sense. So in that sense, you could do the same thing with the graph.
Yeah, these do seem like very sensible functions. I mean, is this a 12.3 type story, or is this something beyond that?
So this would be for 12.3. I could so I would make let's see. So before unfuturizing a doc page, we can meet again when I convert this over to a.
Okay, so something like this isn't going to cut it.
Mm-hmm.
Yeah, I mean, there's some stuff like this isn't going to cut it. You need to have your own, you know. I mean, starry night colors isn't a, you know.
Right. So it should be, I mean, by default automatic, and I can check with Brett or with someone to see what the proper default value, automatic value should be.
Yes, and also you might need somebody from design to work on colors if that is part of the story.
Yep.
And I mean, the way this legending works, that will need to be developed, right? So that you have freedom about how that works.
Okay.
I mean, that might be a default, but it can't be the only thing that can happen.
Right. So I mean, so it should take the legending spec. I mean, so
yes,
being
placed,
yes,
that's usual.
and that
Yeah,
kind of thing.
yeah, all the usual stuff. What does this exclusion function do?
So let's see. So for example, when you want to look at atom chirality, the majority of them will be none. 2 or 3 might be R or S, and it's the R or S that you care about. So it tells you.
So why aren't you just having it be the case that if it's none,
mm-hmm.
then you just don't include it in the, I mean, it's like, look, the way that should work is like color function, color rules. right? Color rules, if you don't specify the rules for a particular thing, it isn't rendered.
Right. I was looking at this. All of the use cases I have for the exclusion functions remove either missing or none values. So we could just remove those by default.
Yeah, I would say so. Seems right to me. And if you want to do this by hand, but look, I think you do want something where you can give. Let's take a look at how this compares to GeoRegion value plot. Okay. Oh gosh, this drives me crazy. What exactly is this doing? It's really stupid, whatever it's doing. What is it doing here? Can you see what it's doing?
I mean, so is
Really dumb. It's really dumb. Look at this. It's in that state, and then it goes to this state, but it has this wave, which somebody must have thought was very clever. Okay. So the analog here would be atom specification arrow value, right?
Yes.
Do we already have something that does something like that or not?
So no. So I mean, let's see. So
yes,
mean,
we
general,
do. We have the thing that highlights molecules, right?
Right. So you could have MoleculePlot, comma, MoleculePlot, first argument mol, and then the second argument a list of atom indices, possibly with a style wrapper.
Okay, fine. So that's what does that.
And that's essentially what molecule value plot is doing. It's making an appropriate molecule plot call.
So why isn't MoleculePlot just taking these second arguments?
Because so the second argument of MoleculePlot already does a lot of work. So it can take patterns. It can take so it can already take a string and take it to be a pattern, I believe.
Oh, what kind of a pattern?
Smiles.
Well, let's find out what it does.
Oh man, I hope I wasn't wrong on that one.
Yeah, it's just for highlighting substructures.
Okay, so that's different. From this. Okay, so MoleculePlot takes a pattern where these things are highlighted, right?
Right.
Okay, so what this is doing is it is applying this function. So in order to get these partial charges for every atom, how do you do that?
Make a molecule value call.
So you say molecule value of the molecule, comma, these things. And so what's the difference between MoleculePlot of molecule value of blah, 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 in MoleculePlot where the second argument is molecule value of that thing?
So let's see. So right now, molecule value plot knows that the second thing can be a property, and so knows to go and look for properties. MoleculePlot wants the second argument to either be a pattern, and it's going to look, are you a smarts pattern?
I understand. Did you understand my question? So my question was, if I put as that second argument, molecule value of the molecule, comma, one of these things, right? So let's say I have the molecule there is caffeine.
And you're going to have to wrap that in molecule.
Why? Why?
Let's see.
Do you understand my question?
I do understand your question. You think that everything that takes a molecule should take anything that would make a molecule.
I think so.
And so I haven't implemented that.
Okay, all right. I think you should look at that and see whether there's a problem with that idea. But if there isn't, I think you should make it work. But okay, so these are the charges by atom number, right?
Right. And so now at this point, then you would need to calculate a color for each of those numbers, and then the thing that you would feed to MoleculePlot would be the molecule, and then a list of style, vertex number, comma, color.
Okay. So here, among the other things, okay, so you've got a color function here, although you probably also want a color rules here. Do you understand what I'm saying?
Well, so we use MoleculePlot uses color rules to determine carbon is this, nitrogen is that.
I understand, but so molecule value plot also presumably needs a color rules to determine how it will color something which says it's a this or it's a that, right?
Right. So it should take all of the. I mean, it should take all of the options
Yes.
that MoleculePlot takes. And yeah.
But wait a second. It's got a molecule plot going on underneath. But the whole point is its color rules refer not to the color of carbon, but to the color of the annotations, right?
Ah, okay.
You see what I'm saying?
Right. Because yes. Because so
okay. There's the same idea as with highlight graph. Highlight graph. In the highlight, you can have a graph which has its own color specifications, but then highlight graph refers to the colors of the highlights. You see what I'm saying?
yes.
Okay, that's how this should work, I think. Although I don't know what the base colors of the molecule should be in that case.
So in the examples here, I make them all black.
I know, I can see that, but I'm asking you, if you had base colors to the molecule, and then some piece of the molecule wants to get annotated. For highlight graph, it's preserving where it can the base colors of the graph, and then overwriting them where it needs to. Did you understand what I'm saying?
Yes.
Okay, so that's what I'm saying needs to happen, needs to be possible here as well.
Okay.
I think Jan, you might want to mute yourself. I'm going to mute you.
So I can take this feedback and make a system doc page for this function.
I think you should. Yes, I think it's nice. Okay, but let me just make a couple of other comments here. So if we look at GeoRegion value plot, okay, it has see, I'm wondering here whether its notion of property is with an arrow, right? It has a region and then an arrow, which the geographic subdivisions in region are colored according to this. You see what I'm saying? So if I were to say, for example, I don't know whether this works, but maybe it does. Arrow GDP, does that work?
So I feel like the analogy.
Wait. Let's understand what that thing is, in which the geographic subdivisions in region are colored according to this. Does anybody know how this works? This is not showing that case. Oh gosh.
I think you got it from Europe.
That's something that shouldn't be able to happen.
That might be hard.
By the way, I just want to comment. Who's project managing here?
Even this is Manu.
Okay,
Yeah.
so the font for that progress monitor is wrong. The font is too big and it's too dark.
Sure.
This is now the third time I pointed out the same thing.
Okay.
Okay, so look at what this is doing. So this is the analog of molecule, arrow, and then, did you get what I'm saying? This is the analog of what you're doing here.
Yes.
Now, the difference is that this has a syntax where it's giving individual regions and individual values.
Right. Molecule value plot could have a syntax where the second argument is a list of rules of index goes to value.
How wouldn't that be the same as MoleculePlot then?
Well, no. So then you still have molecule value plot looking at all the values and getting an appropriate range, applying the color function, and then.
How does it relate to MoleculePlot? Doesn't MoleculePlot? You said MoleculePlot's second argument is right. The MoleculePlot's second argument is a pattern, I see, but it doesn't have. What happens if I want to specify that different elements of that pattern should be colored differently?
So you can specify the second argument for MoleculePlot as a list of indices as the pattern, like a.
No, I understand that, but if I want one index colored red and another, the substructure that is the first substructure in PAT colored red, the second one colored green, etc. How do I do that?
So you can wrap the substructures in style and give it.
Doesn't say that anywhere here. So please fix the documentation.
Yes.
Okay. Also, this should show a list form here.
Yes.
Okay. And I assume I can wrap it with call outs and who knows what else as well, right?
That's what I want to work on next.
So call out doesn't work.
No.
Style works, but call out does not.
Right.
Okay, but you need to document that here. Okay, so the concept here, molecule value plot, would be, it's a perfectly sensible concept that each thing here, instead of it just being a highlight, it is giving a value. And so then the form will be very much the same as this, except the first argument would be a molecule, or you could give molecule arrow and then a property, and it would compute that property for each element of the molecule, just like it does here. Does that make sense?
Yes.
Okay. I think it's a good function then, and the results are very beautiful. All right.
Thank you.
Let's keep going. Right. Lovely. Okay, let's keep going. Those were supposed to be the easy ones.
Indeed.
It's anyway, okay, molecule align. So we just started looking at this one last time, if I remember correctly.
Right. Yeah. I feel I have to warn you that with a lot of the examples, we felt the need to create the molecules, show them before alignment, and then align them and show them after.
Yeah, well, don't do that.
Another way to do that.
Just don't do that. Just don't do that. Just do, look. Just don't do it this way. Just repeat. For goodness sake, what are you doing here? Import of whatever. What? I don't understand what this is.
So in this case, you need two different versions of the same molecule with different coordinates in order to align them. One of them comes from a file, and one of them comes from thin air. Or one is created on the spot. And so they therefore have different coordinates.
Okay, this is a really garbagey way to do this. Okay, so if you're going to do this, see the mistake you keep on making is your examples are too complicated. I mean, if you're going to do this to show aligning molecules, just take water. You don't need something complicated like this, do you?
No.
Okay, so
well, I mean, water is planar, but so specific. I mean,
okay, right, fine, whatever. Something non-planar,
but methane, right?
Yes, right. And what you should do then
can rotate one of the groups, for instance, and then align that.
And what I would do is use iconize, for example, if you want to give one of these things. Don't do this. Do you see what I'm saying?
Okay.
Or alternatively, you could just give. Well, let's see. What does the molecule give? What does this give if you read it in?
So it would all evaluate to a summary box with the molecule in it. So I didn't know if that was preferable to having the import call.
Yes, it is preferable.
Okay.
Much preferable. Yeah, so just use that molecule. Yeah, I mean, just use it for both of them. You don't need to show that what you're trying to show. Okay, look. Okay, technical writing, thing here. Okay, you're just trying to show one thing. You're not trying to show 8 things at the same time, right? The thing you're trying to show is how you align molecules, correct?
Yes.
Okay, so then what it should show is none of this stuff, nothing, none of what's there, right? Nothing of that type, right? So this would presumably say, the first thing it should say is molecule align of, and then you can take these molecules if you want to. Okay, what is that?
It's the aligned result. Stephen, the difficulty with this is that by comparison to something mathematical, let's say you want to take last of a list. You give it the list 1, 2, 3, you say last, you get the result 3. You can see the beginning and the end very clearly. Here we're dealing with 3-dimensional geometries, and we don't get to see the 3-dimensional geometry we're starting from unless we explicitly call that out somehow with MoleculePlot 3D. I understand what you're trying to do here, but we're kind of hamstrung to
Okay,
see.
so here's what I would do. Here's what I would do. I would do this.
You can't use that as input, though.
And how do we see that this has had non-standard, that this has coordinates specified?
Very messily.
No. But here's what I think you should do. Okay. This has no coordinates specified, right?
Right.
Okay. So the first thing is, in this box here, and I'm not saying this for this particular example, but in general, you should say coordinates, and then paren in gray specified or something. You see what I'm saying?
I do.
Or leave them out, right? Because that way we'd know that there's something special about that.
It's a very good idea. I like that a lot.
Okay. So, all right. So the issue here is the alignment is a recoordinatized molecule, correct?
Yes.
Okay, and I assume what's happening is that the second molecule is being aligned to the first molecule.
Correct.
Correct?
Correct.
Okay, so the return thing, if what I did was I tried to align water to this, what would happen? In other words, presumably I can align a fragment.
Right. So so it would probably tell you, so it should tell you that it did not find the reference, the first argument, as a substructure in water.
Which is something I think, Jason, we need to work on.
What?
Because what Stephen has just asked for, we can't do. We can't move water onto something bigger. We can move something bigger onto something smaller the way it's currently set up.
Oh yeah, that's wrong.
No,
I mean,
no,
I should
so
be able
I don't
to get.
understand. I mean, so what would it mean to want to align water onto something?
Find a place where you can align it. Like, let's say this is carbon. Well, I don't know what that is. That's there isn't anything there.
There's an example further down that shows menthol being aligned on top of a sesquiterpene, which is this one here. The blue one is the substructure of the yellow one.
So, but in general, if you want to align
find
water,
that and map it onto it.
Sorry for talking over you. I mean, if you want to align water to something, then you need to specify the atom mapping between water and what you want to align it to.
Well, okay, hold on. If I'm understanding correctly, if there is a substructure, I don't know what you call it. It's not a little something ring, a aromatic ringy thing, What are those called? Just a piece of a molecule. What are those called? The R thingies. What are those? What are the?
So,
What do you
so I
call
like substructures.
Okay, fine. All right. So if I want to align a substructure onto a molecule, this is the function to do that. Is that right?
Yes.
Okay. So in other words, if I have a great big molecule and I say, where does this aromatic ring fit on this molecule? This is the function I would want to use. Correct?
I don't think so.
No,
So if
no,
you
it doesn't.
have, I mean,
It doesn't necessarily do the find. You generally know where you want to put it. In some cases, you can expect it to find the unique place where it would go. But if there are multiple places it could go, then in this example here, there are two different six-membered rings where just a six-membered ring could map.
Absolutely. So I would expect this function.
So you wanted to return two different
That's what I'm
alignments
thinking.
then?
I mean, how would you do that otherwise? Or is that fine molecule substructure?
The fine molecule substructure is topological. It just considers the atoms and bonds, and this is three-dimensional.
right. I mean, this is the function you call after you've already called my fine molecule substructure and you know the corresponding atom indices. So this function molecule align, its primary purpose is so that you don't have to extract out the points, the mapped points, take those points, feed them to fine geometric transform, get the geometric transform, come back to your molecule and apply that to the whole rest of the coordinates. That's the primary thing.
So wait a minute. So
molecule
hold on a
aligns
second. So I mean, if you have molecules which are sort of zippered together at a particular place, like they have these two, I don't know molecules really, but I mean, if they have these two aromatic rings and those are aligned, but they have tentacles that are hanging off in different ways, is that what you would be able to do with this function?
Yes, you could align the two rings and see the tentacles hanging off in different directions.
What do you mean by the word are aligned?
No, if you want to align them, that is, you've got these two molecules
Okay.
and they agree by they have an aromatic ring somewhere and they've got tentacles which are maybe different.
Yeah.
And then you say, align these molecules and align it at the position of that ring.
That's
Right.
what this function is for.
Okay. But the generic case of this function, I see. Wait a minute. What's this uses the molecule pattern? I don't understand what that means.
So in that case, the pattern could be a molecule pattern for a six-membered ring.
Okay, so that's saying at which place to try to do the alignment.
Right. So the pattern is used to generate the list of rules between atom indices and the.
I understand that. But if all I did was I had a disembodied six-membered ring, why wouldn't I want to just say, I've got this reference molecule and it's got a whole complicated structure with lots of coordinates. Now I've got a disembodied six-member ring. Tell me where in that first molecule's coordinate space that six-membered ring would align. Do you understand what I'm saying?
Kind of. I mean, but oftentimes you might want to know, I mean, what kind of pocket does this go into or something? And that's not what this function would do, right?
No, but what Stephen is asking for, the fine substructure would find the different topological mappings, and then you would use align to see which one in 3 dimensions gave you the best geometric alignment between the atoms.
Exactly.
We could do that with this, yes.
So what I'm suggesting is, you do the topological thing off, as automatically here. If I give you a reference molecule like this whatever this is, aspirin, okay? And then I give you a six-membered ring, right? A pure disembodied six-member ring, just 6 carbons here, okay? And then I say molecule align. What I would like to get back out is a version of my 6 carbon atoms with coordinates where the burnt-in coordinates align with this ring here. Does that make sense?
Yes, and the six-membered ring you give it would have to have its own coordinates, and you would get the difference between them in terms of a root mean squared,
Why? Why does it
deviation.
have to have its own coordinates?
because this is a three-dimensional operation.
Okay, I understand, but you could lay that out. I mean, by default, in many cases, just use whatever MoleculePlot 3D would do for those coordinates.
Okay, if a structure is provided without coordinates, they do get generated automatically, but generally this function is used when both moving and reference molecules have geometries, and that's what you're interested in comparing.
Okay, I understand, but there's a simpler case here where where that isn't true. And so for example, let's say we have a planar version of this ring. It's got coordinates, but the coordinates are in La La Land. And then what I want to do is to burn in the coordinates which were appropriate for this particular aspirin here.
From the reference molecule.
Exactly.
Okay, I see what you're asking for, and that's that is a different task.
It's more like a transfer.
Yeah.
I don't understand. Why isn't it the exact same task? Molecule align, as I understand it.
It keeps the molecule rigid. It doesn't.
I know.
Okay, but you wanted to inherit something from the other.
No, I don't. No, I don't. I want to keep it rigid. I want to keep it rigid.
So it sounds like.
But you want to move it on top of the reference one, and if it doesn't have a geometry, give it a standard geometry before you move it.
That's what I'm saying. Yes.
Yeah, that.
But then still, like if you give the standard geometry, it will not fit perfectly.
That's correct. That's why this is an alignment, not a yes.
Okay,
and that's why you're quoting root mean square, minimum root mean square. And if there were two rings and one of them was bent, and the default, flat version of that ring didn't fit the bent ring, then it would tell you it will most likely align on the unbent one. Does that make sense? I mean, I understand that the most common case, but what I'm saying is that there's a substructure that, okay, you could have a complete second molecule as a second thing, and then it will, this here is saying where it aligns, right?
Yes.
Right. I don't think you should have to give, I see. Use the molecule pattern. So this is just telling it, molecule pattern, this isn't clear. Does that pattern apply to mol or to ref?
To both, right? Because
but it doesn't. But it shouldn't be applying to both because their tentacles might be different.
Let's see.
The pattern wouldn't include the tentacles. It would just be the ring that you're interested in.
Okay, fine. I see. So in that case, it's saying it's a region of interest. If this was image processing, it will be a region of interest, which is this is the region of interest to consider for the alignment. Is that correct?
Yes.
Okay.
So one point though that that I heard Bob mention a minute ago, and I think you alluded to also that so if ref is a big thing and it has coordinates and mol is a small thing, it seems reasonable that you might want to still call it expecting mol, and mol is this small thing that is found within ref, right? So in this case, mol could be a benzene and ref could be that aspirin over there, right?
Yep.
So then it would be very easy to do kind of a bilateral substructure search. If ref is small and mol is big, but ref is in mol, then I use that alignment, and vice versa.
But the one thing that's different in this scenario is if mol is small compared with ref, there are many results.
That's correct.
Right. So well, I mean.
But we need a different
output. You can get many results
back.
when you give a pattern also. But the one thing I wanted to point out there though was, so what happens in the case of where you have a lot of things that you're aligning? So where you have this ref and then you have a whole list of things that you're aligning to it. In that case, it doesn't make sense to look. So it only makes sense for there to be a one-dimensional substructure search. So for the case of molecule align ref, comma, list of mols, having ref be the big thing, and then the mols each being little things, and you're looking for an alignment, then that breaks down.
I don't understand this at all.
Yeah.
Let's go through this again, okay? Let's go through it again. You have, for some reason, this idea that the molecules are of comparable size. I do not understand that idea. Why is it not the case that what? Okay, so there are two things you could imagine. You say, I've got this molecule. I agree, they're different relative sizes. Okay, so let's go through the scenarios. One scenario is, I've got this molecule, it's quite big. I want to know, were I to try to, where is, geometrically, where is this ring, right? How would I align a fiducial ring to the actual ring in this molecule, correct? That's one thing you want to do. Do you agree?
Yeah.
Okay. In that case, what you're returning is the ring with its coordinates, whatever coordinates it had before, they've been blown away. Well, actually, they haven't completely been blown away because it is a rigid transformation that you're doing on it.
Yes.
Right? It's a 3D rotation of some kind.
Rotation and translation.
Right. And because this is the real world, there's no scaling.
No scaling, that's right.
Or
and no inversion of symmetry either.
Okay. Okay, fine. So it's a rigid, thing. Okay. But what you're doing is you're taking that little ring, which is specified as a molecule, and you are changing its coordinates. Right?
Yes.
Okay, that's case number one. Case number two is you've got a little molecule first and a big molecule second, right?
Yep.
I don't understand why it's not the exact same thing. You're doing a rigid rotation of the second molecule and you just give the results.
It is. It is exactly the same thing. It's just that the way Jason had set it up first, when you don't supply the mapping, the atoms in the first to the atoms in the second, it tries to infer what that mapping should be with the assumption that the first molecule is a substructure of the second. We thought about using maximum common substructure, but we don't, that's not implemented yet. And that oftentimes doesn't give you what you want.
Right. So the question is, so you could always call find molecule substructure on ref and mol in the correct order and feed that as the third argument of molecule align. Is that true or not?
I think so. I think I understand what you want there. And that's basically, algorithmically getting the mapping instead of typing it in.
However, is it going to be the right way around?
It may or may not, depending. I mean, if you just have a generic 6-membered ring, it could map 12 different ways. Onto...
No. But I mean, right way around structurally here. That is, if I say find molecule substructure, that has the feature that the first argument is the big guy and the second argument is the little guy, right?
Yes.
Okay, so then the order of the rules that returns is big to little, right? Always big to little.
Is that right, Jason? When it returns the mapping?
I'm checking right now. So let's see. So find molecule substructure always returns the rules as little to big.
Okay, fine. All right. So that obviously the right way around, but okay, little to big. Okay, yeah, makes sense. Okay, little to big. Okay, so what the point that I'm making is there's a version of this in which you would have to say reverse /at with respect to these rules to get it the right way around if you used find molecule substructure there.
Yes.
Do you understand what I'm saying?
Mm-hmm.
Which is a little bit icky. So,
and you might expect molecule align once it has done a substructure search and said, oh, ref isn't a substructure of mol, but I was only given 2 arguments. You might expect it to then say, oh, well, I could just do the reverse and see was
well,
mol
I think
a substructure of ref?
Look, the common substructure, the largest common substructure is the right thing to do in the symmetric case there. You may not be able to do it today, but that's the right thing to do going forward. Isn't it?
Right, but then yeah. Then everything gets trickier when you have the list of the second argument. But
hold on, let me think about that for a second. It is a little tricky in that case. Not undoable, but a little tricky.
And
Okay.
common substructure oftentimes doesn't return the thing. You're looking at these two molecules and you're saying it is clearly this ring. It is clearly this ring. Why aren't you returning it? But it isn't, because it's found what it thinks is a slightly larger substructure. So it's not always the intuitive substructure.
Wait a second. Then we need a function that does the intuitive thing. Right? You're not going to get away with that. You knew that going into that. I mean, look, if it does something which isn't what people expect, then it's not doing the right thing. Why does it not do the right thing? I mean, that is, why does it give you're saying that there is a subtle way. I mean, this happens all the time in theorem proving, where, which has the same issue, right? You have to be able to match some particular pattern to some expression. And often those matches are like I've spent like 5 minutes trying to understand how it saw that match, right? In other words, what got turned around in this way and that way and the other way to make the thing match. Is that the issue, that there are transformations? My guess is the reason it will come up with something which is non-intuitive to a human is that there are additional transformations that get made that a human does not simultaneously make.
So the cases that jump out at me are cases where there is a large ring system and it isn't grabbing that whole ring system, because it's found that if it can go off in this branch and include this branch, it'll actually make the match
and get a higher score.
Right.
If it goes out of the
if it creates a linear substructure that includes this branched path over
here.
here.
That's exactly the type of thing that I'm
okay.
referring to in the theorem proving case, that it finds these things which with a little bit of transformation or something, succeed further than the thing that is the obvious thing. So I bet there's a heuristic to get it to do the obvious thing. That seems worth thinking about, because it seems useful, doesn't it? I mean, you don't, since you're saying people want to just say, I've got this molecule, I've got this other one, I want to line them up in this way. If it lines it up with some weird linear thing that it found that was a weird kind of snake that went between a bunch of rings, that they're not going to be happy with that.
Right. And I mean, until we work out the kinks in the MCS, I mean, we can show examples where you use fine molecule substructure to generate a mapping that you feed. I mean, so I just went and said that we could include examples where you first do this and then do that. But can we do that in an example that is below the fold? That is, you know what I mean?
Yeah. I would do that in the application section, Jason.
Okay.
Right, and you can do things in the top section where you say 1 arrow 2, whatever, and just don't build up a giant thing where you're, or if you have to, try and do it in line.
Mm-hmm.
Okay,
Stephen, when we don't supply the atom mapping and there are, let's say, 2 examples where it could go, one ring and the other ring, you would want a list to come back in that?
I don't think
case,
so.
then?
I think you want consistent behavior. I would say that.
Yeah. I'm sorry. Could you?
Yeah, I don't know. I think I think you'd want one of them to come back, but I admit it's a tricky case.
Right. I think of first. So just sending one back, and then we could possibly issue a message and saying that the reference was found multiple times.
I think that's probably not a bad idea. We don't want to have people, but then the question, and then if you want to, and basically say use find molecule substructure to find all the substructure instances.
Right.
Okay, what else do we have to figure out about this?
So let's see. We had originally thought to model it almost strictly along with image align, but the fact that we have to give this atom mapping means that that the call syntax is slightly more complicated, and so we need a method to return the error, and so that's why we have this fourth argument version, where in the fourth argument you can say that you want the
Let's look at
transformation
image align
functions
for a
back.
second. Let's look at image align. You know,
So
this behavior just drives me crazy.
So image align doesn't have to return you back the transformation functions or the error, because it can pass that off to find geometric transform.
Well, what it's doing is it's returning the aligned image, right?
Mm-hmm. Yeah.
So in this case, it's a big image and it's aligning to the little image. Is that right? I can't tell what the heck this is doing. What is this doing?
So it's aligning the second. It's returning a copy of the second where it's been aligned to the first, at least the way I've read the.
Yeah, if you click on the output, you'll see there's a big, yeah, that's where it fits in the frame of the original.
Somebody should make this a bit clearer in this output. So it is redoing the coordinates of mol. Doesn't this have a region of interest, Sue? Doesn't this have to say?
So it has a concept of image key points, but I don't know that you can specifically provide the mapping in a very convenient way, or that and that's necessarily what the users of this function want to do.
No, I don't think they do typically.
You know, you can find your own key points and provide those. I've done that with images.
But we needed to provide give an easier syntax for that.
I mean that, you know, I mean that's just our atom mapping, Jason.
Right. But in image align, I think you need method goes to image key points goes to, rather than having it as an argument.
Could somebody who's here just well, okay, the Manu,
Yes,
this crazy thing with this help viewer, John says he doesn't know what I'm talking about. So could you either send him a fragment of this recording, like from right then, 54
Sure.
minutes, 55 seconds, or ask him to join now? But
Okay.
okay, I'm gonna just send him.
Do you want him to be in the meeting?
Not really, no, I'll send him something.
Okay.
Okay. Okay. Well, let's see. So this thing, I think we've talked about this enough. I mean, you know, the issue here, the only thing that I'm wondering about is those parts of the reference are aligned with those parts, whereas this pattern refers to what? It refers to the reference molecule, correct?
Well, it refers to a part in both. So you find pat in both mol and ref.
Okay. Of which there may be multiple pats in both ref and mol.
Correct.
Indeed.
And
Yep.
now
And what do you do in
we'll
that case?
So what and I think it says
Yes,
this here, we take the first result from fine molecule substructure.
Okay.
Right?
Okay.
It says if ref occurs multiple times, the first substructure
Okay.
match.
So then this, you should say let's find molecule substructure of mol comma ref, or is it ref comma mol?
mol, comma, ref.
which is the other way around from this.
Right. So I
That's
I'll make
not
that
right. That's
clear.
not right. It's not right. It's not right. Find molecule substructure is big, comma, little, right?
Yes.
Okay. This is also big, comma, little, isn't it?
So no, so if you don't provide a mapping, it looks for ref to be in mol.
Okay, I think it's the wrong way round.
Yeah.
Then this multi this list second argument part doesn't make any sense if
Yes,
it has to be
well,
the other way around.
It can, Jason, but generally that's done when you've got an explicit mapping and you know what you want to align in each of those mols to the reference. You know, from drug design, this is where this comes from, and we're trying to handle what I consider corner cases when the user doesn't care a damn about what atoms map to what other atoms.
Okay, but so look, find molecule substructure, it's big, comma, little, right? So we got to reproduce that here. We can't have it be the other way around here.
Yeah, that makes sense.
Okay.
Yep.
So this case here is you've got a little knob that you're trying to attach everything. All these big molecules are all being attached to that one knob. I'm not quite sure why you need to do it that way. Why aren't you just mapping this over that? You know, why aren't you just having a, I mean, I don't see why they all need to be put in this one function. It's not going to do any different than just mapping it, is it?
Yes. If you do the molecules, each one individually against the reference, then you could effectively do the same thing with map, but you can also do the alignment simultaneously where all the molecules, you're minimizing the deviation among them, the n times n minus 1 pairs.
Okay,
And,
so you want
that's explained further down in the documentation.
Okay, all right, fine. But then for your purposes, if right, but these are the big okay. I don't understand. Maybe you need both of them to be able to be lists, but if that's the case, how can this work unless the molecule? Okay, you get the point. It's got to be big, comma, little. Otherwise,
yeah.
But then you're saying big could be a list of big molecules, correct?
No, we don't want a list of reference.
No, generally there's just one reference, but the relative size really does not matter unless you're trying to do a substructure perception.
Okay, fine. But then conceptually, this is big, comma, little. I mean, it might actually be the other way around, but it doesn't. Okay, go on.
If you don't provide a mapping, then you make the assumption it's big, comma, little is one way to operate, yes.
Okay, fine. Fine. Then it's the same as find molecule substructure. Then the way we explain it is, it will, in that case, in that first case there, it will do a find molecule substructure first, and then it will do the alignment, right?
Yes, it would do that.
Okay.
Yeah.
Well, the first approximation that seems reasonable. There's probably a little bit more to look at here, but let's keep going. Maximum common substructure. So is that something specific to molecules, or is that something that is supposed to work for any? Because that name certainly.
It doesn't have the word molecule in it, but it is. I'm not aware of any other field that's interested in maximum common substructure.
I can imagine expressions being interested. What did we call? I'm sorry. Find. What was the thing called? Find molecule substructure. I think it should be called molecule maximum common substructure. I know it's long, but I think it's wrong to just say maximum common substructure.
And so molecule MCS would be out. I mean, so in the community, maximum common substructure is always followed by parentheses MCS, and then they write MCS in the rest of the paper.
It's not totally out.
Because that would be shorter.
I know it's shorter, but there's also autocomplete.
Sorry.
Yeah, but
I think it's wrong to not have molecule in there.
Yeah. think
Do we
by
have-
the time, go ahead,
go
I'm
ahead.
sorry, Stephen. I was going to say, by the time you get to molecule max, it should autocomplete.
I mean, this isn't something where you have 100 instances in one piece of code, is it?
No.
It's the one big punch, and then that's that.
Indeed.
I think you should call it molecule maximum common substructure.
Okay.
Molecule pattern representing the largest common substructure for the input molecules. By the way, you could call it max common substructure. We've done that a number of times. But I don't know, it sounds right to call it maximum common substructure. I think it should be molecule maximum common substructure. What is acceptance threshold? And by the way, that's a mistake, that capital letter there.
Okay.
No, wait a minute. So this is, you're getting this from image identifier and those kinds of things. So it's a number between 0 and 1, correct?
Right. And I mean, it was the function itself has something like a threshold, and so I found acceptance threshold and thought the concept matched reasonably well.
Okay, seems reasonable to me. Anybody else want to opine on this molecule MCS versus molecule maximum common substructure? I prefer maximum common substructure. If you see it in a piece of code, you know what it is.
Absolutely. If you saw molecule MCS, then you would need to open up the doc page to even figure out what it was.
Right. So,
so this would have one new symbol as an option: match parameters.
there's no way you're going to have
right.
a thing called match parameter.
Right. So the sub options, the method options would be match atomic number, match valence, match formal charge, and these are all true or false. And so this was a way of combining them, and you give a list of those things that you would match. So you could perform the match taking all atoms to be equivalent and all bonds to be equivalent, or you could enforce that bond types match or that charges match.
Why aren't you just putting those as a second argument here?
I don't know.
Seems right to me.
We hadn't considered that.
I mean, if that's the thing that just a bag of those things is a second argument. I mean, when you say bond type, that is a property name similar to the property names that you would give for standard molecule property names, right?
Right. But we don't have all molecule or like all atom or bond properties set up in this.
I understand. So there'll be some which give error messages right now.
Mhm.
I mean, some which will always give error messages because they just don't make any sense.
Right.
Like molecular mass doesn't make a lot of sense to give there. What is
Right.
atom stereo?
So that's the R or S, the chiral.
But is that the name that we have for the? Is that the name for the property for an atom?
No, I think atom chirality is the
Okay,
property.
then
That's
then that is what you should use. Yeah. So what I would suggest is that the second argument here is simply, well, either, I mean, I would suggest, yeah, I mean, is there an, yes, is there an obvious default or is there?
So the default that we choose, which is not obvious, but seemed reasonable to me, was to make automatic equal this list, atomic number, bond type, and ring membership. But it's not clear that that's what people would want.
Okay, but are there named combinations that might be useful?
Not yet.
Okay, but I mean, okay. No, I didn't mean that. I'm asking in the world at large, when people ask for the, give me the MCS relative to what, blah, blah, blah.
No.
Okay. All right, fine. Well, then I suggest a second argument of those things because they seem kind of critical to the operation of the function, don't they?
Yes.
That's what I would suggest.
So you have already find molecule substructure, right?
So what shape would the second argument be?
A list.
Then you don't know the order. That's inconvenient.
No, which order?
Of the list elements.
I don't think it matters, Michael.
Oh, okay, good. I thought it mattered.
Yeah.
No.
And if you give just a single one, it'll turn it into a list of one.
Yeah.
And so all of the things in that table could be made to autocomplete. So when you're making a list,
Yeah, that would be
it's
nice.
really convenient.
Yeah.
Okay, what's the third argument here?
How many times do you want to look?
How many, up to how many you want to?
Right.
Okay. Okay. Well, that seems consistent. Seems good. Okay.
Jason, if you said 5 for that and there were only 4, would it fail, or is it
Says up to.
effectively an up to?
It says up to. It says up to. Yeah, it said
Okay.
up to. And you should support it actually being the word up to as well.
That's a good point. I'll make a note.
Okay.
So this next part I feel might be too immature for 12.3, but I need design input to move forward in general. Like what should the API look like for this next topic?
Okay. So is this like image key points?
No.
Okay.
It's like feature vector.
Okay. Is it running in the system here? Can I use it?
Yeah. So those examples that should work.
Why do you pick this unbelievably complicated creature? Maybe you can just read that fluently.
Because I have a list of molecule names that I just grab random ones from.
Oh boy.
Because I'm always amused by or impressed by the fact that Opsin can, and I know that it's going through that and forming the chemical graph based on the name, and that always impresses me.
Okay. Okay, let's talk about how feature extraction works. Right, so feature extraction, I mean, there's a lot of subtlety here because the main issue with feature extraction is we were very worried about what if the algorithm for feature extraction changes in the future. Do you see what I'm saying?
Yes.
And I assume,
molecule fingerprint at the moment, we mainly have so far a set of algorithms that are in use elsewhere.
No, I understand that. I understand that, but you might want to change them someday because modern machine learning has improved and blah blah blah. So feature extraction returns a raw vector in the end. I don't know. I mean, this data structure thing is entertaining, but I don't think it's especially useful.
It does present issues. So essentially, the way that they're currently used, and that's not the most useful part. That's a very unuseful part. I mean, it's how the bit vector is stored by the data structure.
Yeah, all right. Okay.
But in our application, it would be great if normal gave me a list of zeros and ones. But
why doesn't it?
It gives the bytes or
this is wrong. I think you should report that to the data structure people. I think this is wrong. Normal should do. They should have another accessor that does this. Normal should give the bits.
I will file that.
Okay. Okay, let's come back to this. So explain to me how this is used. So you would get some large database of molecules and you would get all of their fingerprints, and then what?
So then you could, when you get a query, you can return those molecules that are most like it. Or oftentimes you might want to return a set of molecules that are diversely different from it.
Okay, so for example, if I did a feature space plot with molecules, this would be the thing that would be the default thing used for the feature extraction for that. Is that right?
Yes. I haven't been able to quite make it that work in my examples. And
okay, but so
that would, yeah.
In that case, this should be able to be the right-hand side of feature extractor.
Yes. So the way I let's see. So if you evaluate molecule fingerprint the way it is implemented right now, without a molecule as the first argument, it returns a molecule fingerprint function, which I envisioned as being the right-hand side for feature extractor or molecule
Why are we
similarity.
even doing it that way? Why isn't it just a feature extractor function? Here's what I think. My first cut at this would be, that you can give it a little cosmetic layer that's about molecules and fingerprints, but below that layer, it should fall through to generic machine learning feature extraction. Because then the whole apparatus with feature extraction and clustering and dendrograms and all that stuff will just work. Do you see what I'm saying?
So let's see. So we've got the layer that I build that can take the molecule and translate it into the bit vector or count vector.
Right, exactly.
And then the machine learning stuff needs to know just how to get those. And
no. The whole point is it already has the apparatus to deal. Okay, let's say you want to make a dendrogram. You've got a bunch of molecules. You want to make a dendrogram showing the family tree relationship between the molecules, right?
Yep. And so that requires a distance function and a feature extraction, right? Is that?
I think so. I'm not sure, but yeah, the distance function. So is there in fact a distance function? Because there's a feature distance. Is there a molecule fingerprint distance?
Something like Tanimoto similarity might work.
Right. So I wrote the function molecule similarity, and so I wrote there's a note about this on the meeting agenda, how essentially chemists talk about molecule similarity. They take fingerprints and compute their similarity. And
right, we have many distance functions that are called such and such dissimilarity, blah 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 blah.
Mm-hmm.
Yeah,
and so
we could use those definitely.
Oh, something like that. I mean, so the point that I'm making is this needs to fit in. So the machine learning framework has two kinds of things, I think. One is a distance metric between objects, and the other is a feature extraction, a feature vector for objects. Now, I don't know at what level you should plug into those things, because the one thing I do think is correct. I mean, the reason it's called dissimilarity is because things that are less similar have a bigger value. Whereas if you call it similarity, it makes it seem like things, if there's a bigger value, they're more similar, if you get what I'm saying.
Mm-hmm.
Right? So, I think it would make more sense to call it molecule fingerprint distance or something. Because that way you don't have that confusion. What do chemists mean when they say molecule similarity? They make the bigger values mean that the molecules are further away. That's really confusing.
No, the bigger values are more alike, and generally the scale is 0 to 1. Just like it's basically 1 minus the dice dissimilarity, or 1 minus the Tanimoto dissimilarity.
Okay,
mathematically, that's what they are.
All right, so fine. So then Tanimoto dissimilarity might be a distance.
Yeah.
Might be one of our collection of distances.
It is.
Of which we have many. Do we have it right now?
So we have Jacquard dissimilarity, which takes a list of zeros and ones and can return a number.
Right.
So those kinds of things, like the Jacquard thing, if there is a way of interpreting that for molecules, we should let it eat molecules as well. Just as I'm pretty sure that things like some of the other distance functions can eat both strings and vectors. Do you get what I'm saying?
I think most, I'm not sure about strings, but the numeric ones will take a vector of zeros and ones, and I did counts with the multi-set dissimilarity functions in the function repository.
Well, hold on. I'm saying you can, if there are dissimilarity measures that both work for strings and molecules in the world, so to speak, then it's easy for us to take an existing dissimilarity function and allow it to take molecules as an argument. That's all I was saying.
So, but then you need the fingerprinting function at that point. So
Of course you do. Yes, you need a whole ball of wax.
So that's why I'm saying Jacquard dissimilarity shouldn't take molecule as the first.
No,
two arguments.
yeah, because it doesn't take images either.
But there is an image distance, isn't there?
Right. So I had written the function molecule similarity, which I can easily change to molecule fingerprint distance. And it can take two molecules. It can take a method that would tell you how to build the fingerprints.
Or molecule dissimilarity might be another way of doing that.
It would also then itself need to take a distance function option to tell you, because we can compare these fingerprints using Jacquard, using DICE,
Euclidean,
mm-hmm.
cosine, whatever.
Okay, fine.
Yeah.
But okay, so hold on. That feels kind of the wrong way around, because it feels like, it should be cosine distance. I don't understand why it can't be cosine distance between two molecules. Why isn't that possible?
It should be.
You need to say how to extract the vectors, how to convert the molecule into a vector.
Right, but so it's one of the two ways around. Either within molecule dissimilarity, you have to give the final distance, or within the distance thing, you have to give the way of feature extracting for the molecule. Right?
Right.
So isn't there a feature distance function?
Based on
Yeah, feature distance. Here we go. So now feature distance has a feature extractor, and then what does it find? Oh, there we go. Distance function. There we go. The distance in the feature used in the feature space. So that's the analog. So your thing would be an example of a feature distance where the extractor is your molecule fingerprint.
Yeah.
And then distance function is one of these Jacquard, cosine, whatever else it is.
Okay. Yeah.
Makes sense?
Mm-hmm.
So this should all plug together. I mean, feature distance should be able to take as an extractor. I mean, I don't think it necessarily needs a standard feature vector. I think it just needs, I think that I don't know whether this needs, and you need to look it up, what it needs to get back from the feature extractor. I suspect it's a list of numbers, but I don't know. Okay.
So I've actually toyed with a feature space plot with these fingerprints, and it can lay them out, and it obviously sees some kind of pattern. What I meant by I couldn't get it to work was I couldn't get the tooltips to show nice little plots of the molecules. But that's
a different issue. Yeah, right. But I mean, so what you're saying is feature space plot, feature extractor, arrow, molecule fingerprint, basically, is what you're talking about.
Right, and feature space plot also takes a distance function, which would be the molecule dissimilarity of.
Right, and then feature distance. Okay, so in principle, molecule dissimilarity is a one-liner that just says, okay, so I think following I kind of, maybe it's too long and ponderous, but molecule dissimilarity distance. No, molecule dissimilarity is the right thing, I think.
I like it.
Okay, so then so molecule dissimilarity would, like feature distance, get a distance function, which is its final cosine whatever thingy, right?
Yes, what to do with the once you've converted things to numerical form or whatever their final form is, what operation do you do?
Right. Mm-hmm. And so its feature extractor, so its main argument structure would have to do with the way the feature extractor works. Okay. And then what you would do is plug into some of these other functions like feature space plot and learn distribution and so on. You would plug in that the default feature extractor for molecules would be this thing here.
Yes.
Okay. Sound reasonable to me. Now, when we have okay, does it matter that these things are a bit, it's magnificent using all the data structure stuff, but does it matter that they're very packed objects or not?
Let's see. So the bit vectors, it can matter if you have a lot of them. It can be nice.
Well, I know.
To store them that
Is
way.
that a common thing that you have?
It is common to hook these things up to databases. I haven't explored connecting them. So it's common to use these things in cases where you have more of them than you would normally store in your memory in a desktop computer.
Okay.
Yeah,
Well, so-
I
go
can
ahead.
For a
confirm
given-
that just
Go ahead, Michael.
no, just from Emu at a conference at the UFI physics department. Yes, kind of. They looking up from hundreds of millions of fingerprints is definitely an important thing of the future. People agree on this.
And I was
Okay.
going to say that
So where do you store those? Where do you store the fingerprints?
So in the SQL table,
But I don't think so, because the lookup there isn't going to do a very good job. It's not going to
So
give it the similarity distances.
there's a cartridge, and I'm not sure what a cartridge is because I don't know Postgres, but the code that we're using to generate these fingerprints has a Postgres cartridge that does.
Okay, so it's like Postgres has geo stuff in it as well
Mm-hmm.
for finding geo distances.
And so there it can find, do these Jacquard and Dice distance metrics over serialized forms of the fingerprints. But I have not explored that.
Okay, so it's probably similar to the way it does geo distances. So for us, then, another function that we'll eventually have is a find molecule where you give it a fingerprint, or where you give it a molecule and it's finding a similar molecule by fingerprints.
yes.
Do we not have such a thing already?
No, we don't.
Okay, so there'd be a nearest molecule or something.
So in the I put some in the function repository PubChem similarity search, which is a nice wrapper around a service connect, and it does.
Okay.
They are doing that.
But so what this is like geo nearest. This would be molecule nearest.
Yes.
And it would give you in the database, just like GeoNearest gives you the nearest city, river, whatever else. Not sure if it does rivers. Rivers are obviously more complicated. Okay. Okay, so does this basically answer the questions right now look, in terms of the return value for the fingerprint thing?
I think
It's not important that they're data structures at the moment. So yeah.
I know, but the question is an opaque wrapper that comes back. And we made the decision for feature vectors, which you could ask the machine learning team why this was done. I remember long discussions about it. Probably live stream discussions, we'll probably find them, about why feature extraction should return what it returns. And the big obsession there was, what if a feature extractor changes, right? You have a piece of code and there was some quite clever mechanism for how it stores versioning information in the feature extractor. Okay. But the decision was made there to return a raw list of numbers from the feature extractor.
I think
So
Jason's, sorry.
Go on.
I think Jason's question was mainly if the step from the fingerprint to the fingerprint function is the right thing.
And the other thing, at this point, when we had the feature thing, we didn't have the new structures, which comes with the compiler. So this is new functionality with the bit vector thing, which I think is pretty new.
Right. So I think there's still going to be a lot of unanswered questions about fingerprints that the design isn't going to be quite ready for 12.3 unless we want it to be very experimental. I mean, because
right now I agree, but I'm saying, okay, molecule fingerprint, given a particular type of fingerprint and given a molecule, you're going to get back something. Right now, you're getting back a bit vector, but you could get back something different. You're going to get some lump of stuff that is some kind of fingerprint, right?
Yes.
Okay, what is the fingerprint function supposed to be?
It's basically like linear solve. Like you frequently want to use the same fingerprint type on many, many molecules.
What's to make it an operator form?
Right. So, I mean, so as I understand it, like you've got feature extraction, which creates a feature extractor function. Although in that case, feature.
No, but that's because it has
extraction does some-
learning. That's the
yeah.
reason it does that, is because it is the whole point is that feature extraction is learning from your data. You're not doing that. You do not need two things.
But nearest function, linear sort function, it's exactly the same thing.
You can use it as well.
No, it
Why
isn't.
not?
Michael.
Why
No,
not?
it isn't. It isn't. It isn't.
Why not?
Because nearest function is taking the particular set of, okay, you could have a nearest molecule function or molecule nearest function that works like nearest, where you give it 1,000 molecules and it will prep for you a KD tree or whatever it's prepping, so that every subsequent
Yes.
molecule you ask about will be fast. That will be a worthwhile function. Molecule nearest. Okay.
But
That seems to, yeah.
But making the fingerprint also needs a lot of parameters. So also there's a lot of preparation involved.
No, but I know, but it's just but there's no runtime preparation. It's just that you specify this complicated thing with a lot of parameters, which I claim should be an operator form of molecule fingerprint.
Right. Okay. So that, I mean, that is doable. And so molecule fingerprint of just the method will kind of remain unevaluated.
Yeah, and it
And
can
will
make itself into a blob if it wants
Mhm.
to.
I
And
mean,
then
so
you
the
apply
only-
it to a molecule. It's
the
an
only
operator
problem I
form.
had with-
Yeah, go ahead.
Is that the name molecule fingerprint, you might expect that it itself is a wrapper for the data type and not necessarily a function. So I had originally made it molecule fingerprint function just as the operator.
No, absolutely not.
Okay.
No. I think what we want to do is follow what we've done for feature extraction. Right? So I agree that the molecule fingerprint is complicated and ambiguous, but the things that are clear. So having a function called molecule nearest, which works using fingerprints, seems like an obvious thing to do.
Yep.
Right. And it would, so what is the head of the, so molecule nearest of moles, and then method goes to, and that's where you put your thing that is your feature extractor function, or that is the molecule the operator form of the molecule fingerprint.
I would think so. I think so. And then molecule nearest would have a one argument form where you've given 1,000 molecules and it will prep a nearest function that you can then use on individual molecules. Right?
Right.
Right. Although
Okay.
I don't know a clever way to do it at the moment. I know that there should be, but I know, so I have it.
Well,
coded up to do
you
brute
just
force.
use the way that nearest does it. Just use what nearest does.
I think that doesn't work very well in this
Oh.
super high dimensional spaces.
Okay, fine. Fine.
Okay, so you're saying the similarity to be canning this for 12.3 and punting it for a later release.
I don't think we need, I mean, I don't know. What's the deadline?
This fingerprinting was always an offering for the machine learning group that we can use it for machine learning, which you
So it
requested for a long time.
So, right. I mean, what is the deadline? That is the question.
Okay, so
of the hour,
why don't
but,
you put it in as a
mhm.
featured extractor in the machine learning system? And then putting it in with its own custom things in, with its own custom wrapping for molecules is a separate thing. But just make it one of the feature extractors. Just give them it and tell them to put it in as a feature extractor.
Okay.
Then it'll just work. I mean, the feature extractor can have all kinds of weird arguments. That's what feature extractors do.
So in doing so, do I tell them? I mean, hook it up to system backtick molecule fingerprint, which I mean,
I don't care what you do there. I mean, it's as far as this is concerned, it's just, look, I don't know why this doesn't have a link to the feature. Where the heck? Where is the list of feature extractions that you can do? Oh, here it is. Okay, so here's the list, right? So just give them one for molecule and have it work by default when you give molecules there. And I don't know, again, you should ask them, because I don't know where the extra parameters for these go. Do you understand what I'm saying?
yes.
Right? But you should just give it to them so they can hook it up here. And if you need to have multiple names, if you want of common, fingerprint methods that you can give as named things here, like you have multiple spectrograms here. Okay, and then all of our machine learning stuff will just work for molecules in the first instance. Make sense?
Yes, yes.
Yep.
And then we can loop back and look at it as a custom thing, which has more bells and whistles later.
Yeah, this sounds good. Let's try that
Okay,
for now.
great. All right. I think that I need to run off to something else here, but I think we got through the main agenda here.
Yeah.
Good. Looking nice.
Thank
Lots
you.
of good things.
Thank
Yeah.
you.
Very good. Okay.
Okay.
See you all.
Thanks,
Thanks to
Stephen.
folks on live.
Thank you.
Okay.